No conditions, no loops inside, but yet it is still somewhat interesting to do. Okay, let's see. How do I change this bar here? Okay. That will do it. Okay, here's the code. So we have line 1, t gets the value of x. Line 2, x gets the value of y. Line 3, y gets the value of t. Oh, okay, well, that doesn't seem hard at all. Nothing seems to be, no right-hand side refers to the left-hand side, so it's going to be a whole bunch of forget operations, right? And we'll say that the pre-1 is something like this, okay? Pre-1 is, I know something about x. I know x, has the same value as some constant a. I don't know what it is, I just say that, pick some a and x equals to a initially. And we'll say that y initially equals to b. That's the precondition. Okay? I don't know exactly how x and y relate to each other. I don't know anything about t at all. All I know is x equals a and y equals b. And we want to go through this code and find out what it is going to do. Is that okay so far? Okay, let's go ahead and do it. I think some of you already know the answer to this. You have seen this code somewhere. This is a really, really useful sequence of code to do a specific thing. So we'll figure out what specific thing it does that makes it so useful. So we have post 1. What is post 1? Post 1 is the result of the forget operation applied to pre-1. What am I going to forget about in pre-1 in this case? What is the variable on the left-hand side of the assignment? T, okay? And after that, I know one thing for sure. I know t equals to x, don't I? Because after all, the statement on line 1 states that t is going to get the value of x. Okay, great. Let's go ahead and carry out the operation. Pre-1, okay, so I will do it by spelling out everything. So I'm not going to skip any steps here. X equals a and b, y equals b. Does it mention t? No, nothing about that. So now we can say x equals a and y equals b and t equals x. Okay? Now, because we know t equals x and x equals a, can I also say that t equals a? Sure. It's not adding anything new to the whole thing, but it does not conflict with it either. It's just unnecessary, right? Okay, so we'll just keep it here because it will come in handy. Now we'll deal with, and this turns out to be the same as pre-2. Are we convinced that post 1 is pre-2? Because they're in a sequence, one is following the other. Okay, so now we start with the other one. We say pre-2 is that, so we want to figure out what is post-2. So post-2 is going to be also based on the forget operation, based on pre-2, and this time what are we forgetting? Anything that mentions x. Very good. So anything that mentions x we have to forget, but after this operation we also know that x equals y. So we'll go ahead and actually do the calculations here. We'll expand what is pre-2. We'll take the entire thing of pre-2, paste it here. Okay, well, x appears here, so that has to go away. X appears here, so that also has to go away. Right? So that means I have y equals b, that part I can keep. T equals a, I can keep 2. And also x equals y. Are we okay so far? Okay. Now that I know x equals y and y equals b, can I say something else? Can I say and x equals b? Would that conflict with anything? That wouldn't conflict with anything, right? X equals y, y equals b, hey, no problem, x equals b. And that turns out to be the precondition of line 3, because line 3 follows line 2. So now we want to derive post 3. Post 3, once again, is based on the operation forget. Okay. This time, what are we forgetting? anything that mentions y. Very good. And after this operation, we know that y equals to t. Okay, very good. So we expand what is pre-3 or what is post-2 because they are exactly the same thing. We paste the whole thing here, and y equals t. Now we actually go ahead and perform the forget operation. This part mentions y, it has to be forgotten. This part mentions y, it also has to be forgotten. So what I can keep is t equals a, and x equals b, and y equals t. Is that making any sense so far? Because t equals a, and x equals b, and y equals t, can I just add and say redundantly and say y equals a? Because equality is transitive. Y equals t and t equals a means that y equals a. Okay, so now I want to kind of regroup things a little bit here. I want to just focus on the part that I'm interested in first, and leave the rest later on. Okay, the rest is not nearly as important as this first part here. Okay, if you look at this part here and look at this part here, what do you think this sequence of code is doing? I can tell you that t is not a very useful variable. After this operation, I can toss it away. It's not important to me. But as far as x and y are concerned, what did I just do to the values of x and y? They're swapped, exchanged. Okay? In other words, these 3 lines here is used a lot in computer programming. Whenever we need to swap the content of 2 variables, we have to use this code. Okay? But did you guys see how we can just prove that this code is going to work without a single test case again? Because I didn't throw anything at it. I did not throw any test case at the whole thing. All I did is to go through the mathematics, and it proves that it will work all the time. Okay? Let's go ahead and take row first, before before it gets too close, before people are.
I was going to say, can you scroll down so I can see the bottom?
Yes. This is the important part. Okay. So let me go ahead and take row first. And after we take row, we'll probably still have a few minutes left, so we can still cover a little bit more. In other words, I want to show you what a dead branch looks like from the perspective of pre and post conditions. So I'm trying to relate, these topics that are fairly new to all the things that we have talked about before, so that you guys understand, all the old things, that we have talked about. How do we see those things from the perspective of pre and post conditions? So we'll do all that stuff after I take row. So I have a lot of tabs opened up now. Okay, is Fadi here? Okay, very good. Ria? Ali? Nope. Okay. Come on, anytime now. Okay. And Christopher Bender. Thank you. Ivan? Thank you. Is Ed? Ed, okay.
Here.
Okay, thank you. I recognize some of these names now because I finished grading the homework assignment, so it's, I know that name. Amitesh, okay, thank you. Lou?
Here.
Thank you. Jennifer?
Here.
Thank you. John?
Here.
Thank you. Michael?
Here.
Thank you. Queen, okay, thank you. Benjamin? Nope. Mitra? Mitra, sorry. Okay. Isaac?
Here.
Thank you. Laura?
Here.
Thank you. Marco?
Here.
Thank you. Brian? Brian's not here. Leslie? Not here. Joshua is here. Joseph. I think he was here and he did not feel well, so he had to leave. And I remember specifically because I asked him, was it because of me or the material of the class, and he said, no, it's not. I think he's being polite. Kyle.
Here.
Thank you. James.
Here.
Thank you. Lan.
Yes.
Thank you. Daniel.
Here.
Thank you. Christian.
Here.
Thank you. Aaron.
Here.
Thank you. Moving on. Jeffrey.
Here.
Thank you.
Maggie.
Maggie. Thank you. Okay. Timothy.
Here.
Thank you. Vadson.
Here.
Thank you. Yep. See a picture. That's good. Kind of pixelated though. I'm just making random comments here. Manpreet.
Here.
Thank you. Raphael.
Here.
Thank you. Maurice.
Here.
Thank you. Alexander.
Here.
Thank you. Very good. And Tia is not going to be here because she moved on to my Tuesday, Thursday class. Michael.
Here.
Mikhail. James.
Here.
Thank you. John is not here. Kyle.
Here.
Kyle Woody. Thank you. Tammy.
Here.
Thank you. And there we have it. Okay, so now we have 10 minutes left, more than 10 minutes, which is great because we can actually figure out what a dead branch will look like from the perspective of pre and post conditions. Okay. Every year I teach this class, I actually get to teach a little bit more because I have never thought about it that way before, and then I suddenly realized, hey, I can see it from a different perspective, or I can use this method to see something that I have not seen before using this perspective. So that's all really cool. Okay, so we'll go ahead and make one example out of a really obvious example of a dead branch. Okay, if x is less than or equal to 0, then line 2, y gets 0. Line 3, else if x is less than, I don't know, 0. Okay, then line 3, y gets 1. We have 2 line 3s. Line 5, else line 6, y gets 2. Okay, line 7, and if. That's my pseudocode. And if you look at this pseudocode, you probably know which one is the dead branch. Do we have 1 or 2 dead branches, by the way? We got 1 dead branch. Okay, we have 1 dead branch between 2 live branches. Okay, let's see what. Remember what I said? We can use pre and post conditions to figure out which one is the dead branch. Okay, so let's go ahead and do that. Pre1 is true. In other words, I don't know anything about x. I don't need to. Okay, and then we can say, what is pre2? The precondition of line 2 means that we are about to execute line 2. So what do we have to confirm at that point? We know pre1 still has to be true because we have not had a chance to change anything. What else has to be true? X is less than or equal to 1, right? Sorry?
You said it's 1.
Oh, sorry. X is less than or equal to 0. Thank you. Okay? I mean one thing, I say another thing. And I can do that without even thinking. I will make a perfect politician. Because I will even pass the lie detector thing because that's just the way my brain works. I'm a natural liar. I don't need years and years in the government to train myself. I can just do it without even thinking about it. Okay, which means I can be caught by enemy spies and they can get information out of me, and it will only do them more damage. Okay. And this whole thing becomes x is less than or equal to 0, right? And then we can move on to